Hello all, this is Cristobal Dina from Trinity Software. Welcome back to part 2 of Statistics for Data Science using Python tutorial. In this video, we will see measures of shape and association in descriptive statistics. These are the packages to be imported, executed. Let's start with the measures of shape. Describes the distribution of the data within a dataset. To measure the shape of distribution, two methods are available, namely skewness and kurtosis. Skewness means data leaning towards one side and kurtosis means tailedness. Skewness measures the asymmetry of the distribution of a variable. So this is the formula to find out skewness, where mean is the average value of the dataset, median is the middle value in the dataset when sorted, and standard deviation is a measure of the spread of the data. So this formula helps in determining the degree of asymmetry in a dataset's distribution. This is the visual representation of positive skew, symmetric distribution, and negative skew. A positive skew indicates that tail is on the right side of the distribution, which extends towards more positive values. So in this case, the mean is greater than median, which is greater than mode. The majority of the data is concentrated on the left side of the distribution, and there are a few high values on the right side. Example can be a dataset of incomes of 500 people, where most of the people will be having low incomes and few have high incomes. So the distribution of incomes would be positively skewed. Okay, a value of 0 indicates that there is no skewness in the distribution at all, meaning the distribution is perfectly symmetrical. In normal distribution, mean, median, mode all lies at the center point. The example can be a dataset of heights of 100 people. If the distribution of heights is symmetric, it means that majority of the people will be of average height and there will be very few people who are very tall or very short. Okay. And negative skewness indicates that tail is on the left side of the distribution, which extends towards more negative values. Here, mean is less than median, which is less than mode. Majority of the data is concentrated on the right side of the distribution. Example can be the age of retirement for people in a particular city. Most of the people retire at the age of mid-60s. Only few people will opt to retire much earlier. So it means long tail of lower values on the left side of the distribution. Okay. Now let's take an example and find the skewness using Python libraries. This represents the exam scores. Using stats, which is a SciPy subpackage, you can find out the skewness, that is stats.skew method. Pass the x as an argument. On executing, we got a negative value here. Minus 0.19 means that it is a negative skew. So we can visualize skewness using Seaborn, which is a Python data visualization library which contains built-in datasets that are perfect for practicing various data science concepts. So here are the built-in datasets in Seaborn. Let's take this diamonds dataset and we can load that. We'll store it in a variable d is equal to sns.load underscore dataset. Dataset name is diamonds. Now we can view the first 5 rows of this dataset by using d.head method. So it displays the first 5 rows of that diamonds dataset. Now let us examine the column carat and diamond price. Okay. After in the pandas series for diamonds price using d of price. And also we can obtain carat. D carat equal to d of carat. Now we can find out the skewness using the pandas method skew. D underscore price dot skew method. The skewness for the column price is 1.61. It is positively skewed. We can also find out the skewness for all the numeric valued columns in the dataset by using d.skew passing numeric only argument. Numeric only is by default false. Now we are making it as true. So now we'll get the skewness for all the numeric columns in the dataset. For price it is 1.61 and for carat it is 1.11. Both are positively skewed. Okay, fine. Now we can also find out using SciPy, that is stats.skew method, find out for the separate column d of carat. Okay. Now let's see what is a kurtosis. Kurtosis describes how much area is in a distribution tails relative to the normal distribution. Kurtosis measures whether your data set is heavy-tailed or light-tailed compared to a normal distribution. This is the formula to find out kurtosis. Here xi is the data point of x, x bar is the mean of the given data, n is the number of data points, and s is the standard deviation. Kurtosis indicate the presence of outliers and describe the overall shape of the distribution, such as having heavier tails called as leptokurtic, lighter tails is called as platykurtic. You can find out the excess kurtosis by using formula kurtosis minus 3. Based on the kurtosis and excess kurtosis, we have three types of kurtosis, that is mesokurtic, leptokurtic and platykurtic distribution. The example for leptokurtic distribution is the stock market returns. Stock markets often experience extreme events like crashes or sudden spikes, so it is a leptokurtic distribution. The other category is platykurtic, indicating fewer extreme values. An example is the distribution of outcomes in rolling a die. You will get a value from 1 to 6 only, so there is no extreme values there. So this will be platykurtic distribution. Mesokurtic is a perfect symmetric distribution, normal distribution. Okay, here using pandas we can find out the kurtosis for the diamonds dataset itself. D dot kurtosis by setting the numeric only value to true. So this is a kurtosis. You can also find out kurtosis for a separate column, d of caret dot kurtosis. So this is kurtosis for d of caret. Okay. We can also obtain this kurtosis using stats subpackage, stats dot kurtosis. We can find out for d of price as well as for d of caret. D of caret. So this is for d of price and this is for d of caret. Now let us visualize the skewness and kurtosis in Python. So two plots to visualize, that is histograms use bins to represent the data frequencies and KDE plots use a smooth curve to estimate the probability density. Comparing both, KDE are better at showing the shape of the distribution than histograms. We will plot KDE now using SNS.KDE plot. We can plot it for D price and you can set the title plot dot title KDE plot of diamond prices and plot dot x label is price. Okay, execute it. We have plotted the KDE for diamond prices. So this is the smooth curve which we have obtained. From this distribution, we can infer that it has a long right tail indicating a positive skewness and it has a very sharp peak which corresponds with high kurtosis. So similarly, we can also find out the KDE plot for diamond carats. Instead of D price, let me give D carat. KDE plot of diamond carats. Next label is carat. Okay. So now KDE plot of diamond carat is not as smooth as that of the diamond price. So you can increase the smoothness of the curve by increasing bandwidth BW underscore adjust parameter of KDE plot. So in this KDE plot itself, you can include BW underscore adjust. By default, it will be 1. Now let us make it as 3. We can also change the color. So by default, it is blue. You can change it as red. You can see the difference. We got a smoother curve now for diamond carat. Okay. Also, we can plot the histogram for diamond carat. SNS dot hist plot for D underscore carat. And you can give the same thing, plot dot title and plot dot x label. This is histogram, plot of diamond carat, and x label is carat. So if you execute it, we got the histogram. Here we can see the bins must be reduced. That's a disadvantage of histograms. We have to choose a number of bins by ourselves. Let's decrease the number of bins to 25. Bins equal to 25. So now number of bins is 25. Okay. Now we can combine the KDE plot and histogram plot together in a diagram. We can give plot dot figure. Fixed size is the argument. It has 10,6. Now we are going to plot SNS dot hist plot for D underscore carat. Bins can be 30 as you wish. And we are going to combine both. So KDE parameter is set to true. And also we need to adjust the bandwidth. That can be done using KDE underscore KWS. It is set to ticked off bandwidth underscore adjust equal to 3. You can also change the color. The color is equal to green. The other things are same. Plot dot title and plot dot x label. So we can give histogram and KDE plot of diamond carat. So execute it. We got the combination of histogram and KDE plot of diamond carat. Okay. Now let's move on to the next measure in descriptive statistics, that is measures of association. There are two measures, covariance and correlation. These measures are useful when you want to compare and quantify the relationship between two variables. Covariance determines if the two variables are related. Correlation measures how they are related. So what is covariance? It is a statistical measure which determines the direction of the relationship between two variables. So the relationship between the two variables indicates whether they tend to move in the same direction or opposite direction. So this is the formula to find out the covariance. Xi is the data value of X, Yj is data value of Y, X bar is the mean of X, Y bar is the mean of Y, and N is the number of data values. There are three possible values for covariance. It can be 0, it means that the variables are not correlated at all. Covariance of xi, xj greater than 0 means that the variables are positively correlated, and less than 0 means that variables are negatively correlated. If both variables tend to increase or decrease simultaneously means they have a positive covariance. If one variable increases while other decreases means then they have a negative covariance. We will see an example. These are the two variables, study hours and corresponding exam scores are given. We can infer from this data that as the number of study hours increase, the exam scores also increases. Okay, let's find out the covariance using the statistics method. Statistics dot covariance. We have to pass both the list, that is hours, comma, scores. So we got 39. They have a positive covariance. It means as the one variable tends to increase, the other also increases. You can also find out this covariance using NumPy. np.cov, two parameters, hours, comma, scores. So here we got a matrix. This is the format for that covariance matrix. It is a square matrix that shows how variables in a data set relate to each other. The diagonal elements show the variance of each variable. That is 7.95 is the variance of study hours and 197.47 is the variance of exam scores. And this is the covariance of x comma y, that is study hours comma exam scores, and this is the covariance of scores comma hours. If these two are the same, it means that the covariance matrix is symmetric, as covariance of x comma y is equivalent to covariance of y comma x. Okay, we can also find out the covariance using pandas. Here is a dictionary with the height and weight of 5 different people. Now let's first create a data frame. df is equal to pd dot data frame. Pass d as argument. Now you can find out the covariance, df dot cov method. So we got covariance matrix again. So variance of height and variance of weight. Here covariance value is 187.5. Again it is a positive covariance. Okay. We can also obtain it separately, that is covariance of height comma weight. It can be obtained in pandas by just using df of height dot cov, covariance of df of weight. So we got covariance value, that is 187.5. Similarly, we can find out correlation. It actually measures both the strength and direction of the relationship between two variables. Covariance measures only the direction of the relationship. Correlation also measures the strength of the relationship. Okay, this is the formula to find out the correlation. Correlation is a function of covariance, and from this you can always infer that a positive covariance always leads to a positive correlation, and a negative covariance always leads to a negative correlation. And correlation is considered better than covariance because correlation is standardized, whereas covariance is not standardized. It means that here covariance value range from minus infinity to plus infinity, whereas correlation values from minus 1 to plus 1. Okay, using NumPy we can find out the correlation for the same example, hours and scores. NumPy method is COEF, correlation coefficient. Pass hours comma scores. So this is the correlation coefficient matrix of the variables. Here this 0.98 means that it is a positive correlation. Okay, the default method to find out the correlation is the Pearson method. Apart from the default method, two other methods are available. You can check the output of the other two methods in pandas, that is Kendall method and Spearman method. Default Pearson method will evaluate the linear relationship between the two variables, whereas Kendall method measures the ordinal association and Spearman method evaluates the monotonic relationship. Here let us take another example. we have a dictionary with temperature and coffee sales. As you can infer from this data, as the temperature increases, the coffee sales decreases. So it is a negative correlation. We can verify that by creating a pandas data frame. Df is equal to pd dot data frame, and data is the argument. Now we can find out the df dot correlation. So if no argument is given, means that correlation is calculated using the default JSON method. That's a negative value, minus 0.93. We can also check this with the other two methods by passing the method argument. So we can give df dot correlation method equal to Kendall method, and the next method is Spearman method. Now let's check the output. So the first one is the default method minus 0.93, and Kendall method it is minus 0.96, and Spearman method is minus 0.9. Okay, this output is actually the correlation matrix that displays the correlation coefficients between all pairs of columns in the data frame. We can also find out the correlation coefficient for two columns separately. df of temp dot corr, df of coffee sales. So here minus 0.93832 suggests the strong negative linear relationship between the temperature and the coffee sales. Okay, that's it with the part 2 of statistics in Python. Thanks for watching. If you like this video, kindly share and subscribe.